strong.
So that,
It's strong.
when that
It doesn't go back.
plus,
You don't make a pencil look.
So that's why you have to like breathe, because it gets the carbon dioxide
Yes.
out and out.
Yep.
The Chris
Yeah, if you weren't breathing, you build up your CO2.
Yeah.
Not good.
You're not shut up. You don't have an album.
Yeah. Now, the question is, what other things are amphoteric besides water? What else can you have that can gain a hydrogen or lose a hydrogen? Watch this.
Me.
Does it have a hydrogen it can get rid of?
Yeah.
Yeah, so it could act like an acid.
Oh, it
Can
can.
it take a hydrogen? Yeah, if it took
Yeah.
a hydrogen, that would make H2CO3.
Your favorite thing. That's on your shirt.
Yes.
Have you seen his Hollister's shirt?
No.
It's like.
All right,
changed-
so
yeah, it's CO3
anyway,
to
we're going to see a lot of
H2CO3.
things that are amphoteric in the next chapter on buffers. Buffers are acid-base systems where you're mixing them together. We'll talk about it then. Let's move on. Let's talk bases. All right, so number 93, I don't think this was one of the assigned homework problems. Calculate the pH and the hydroxide concentration of this NH3 solution. Now, let's talk about this. Is NH3 an acid or a base? I didn't write the chemical equation up here because I want you to do it in a moment. Let's go ahead and do that right now. The major species present, what do they mean by that? Go ahead and write down the chemical equation first, then we'll talk about major species. What does NH3 do when you put it in water? If you had told me that it's a base, your chemical equation should look something like this.
Is it a strong base?
There are some
NH3?
strong bases.
No?
You're not going to see anything here.
Can you remind us of the strong bases again?
Yeah, strong bases are group 1 hydroxides, like sodium hydroxide, potassium hydroxide, and then the bigger group 2 hydroxides, calcium, strontium, and barium hydroxide. Those are the strong bases. So, Boomy, did you hear that? Anytime you have those strong bases, then it's the same as strong acid. The pH is whatever
Wait, are there 6 or 8?
Group 1s or calcium, strontium, barium, the bigger group 2 hydroxide.
So there's 8?
Yeah.
Oh.
Okay.
No, there's 6
What atoms
strong
are,
acids, right?
What molecules
And then
or
there's
ions
8
are
strong
present
bases.
in the high concentration? Specifically, which ones? In that solution, what would we find the most of?
It's the
Is it okay if I
Illuminati.
erase this now, or does this need to stay up? Do I have to put save next to
Yeah,
this?
yeah. Please put save. Why'd you even ask?
Because I want to know. Do you have a chemical equation?
We
How many terms are in it?
quattro. I think.
You were multilingual on that one.
Ooh.
Oh, no. Yeah, you said we, didn't you?
Yeah.
Yeah, French and Spanish. I'm very impressed.
Wait, we is yes, right?
Yeah, I'm savage. Well, what do you mean?
Oh, you said do you have a... Oh,
I speak like 20
Oh, dang.
languages.
well, you take French, right?
Is this our reactant
Fight.
side?
Yeah, that's right.
Yeah, it
Just
is.
say yes then.
We.
Okay, now what's the product side?
NH4 plus OH
Yes,
minus.
this thing is a base. It takes a hydrogen from the water, yeah? And we get ammonium ion and hydroxide. Okay, so now we're going to make an ice table out of this thing. Before we do that though, let's talk about major species present. What would we find in this solution? If you have the ammonia water reaction going on in some container, what things are you going to find in the container? Anurag? Go ahead.
So is NH4 the conjugate acid?
Yes, NH4 would be the conjugate acid of ammonia.
Wait, is it ammonia usually a base?
No, it's an acid. Ammonium cannot accept a hydrogen.
Right.
This thing right here, it can't take, when it takes one hydrogen, that's it, it's done. It can't take another one. It can get rid of a hydrogen, which makes it an acid. All right? I forgot what I was going to ask now. Oh, the major species present. If you could see this ammonia in water, what would you, what substances are in there?
NH4.
Yes, you would find NH4. What else would you find? OH, you'd find some hydroxide, yeah? What else would be in there? There's even more of something in there.
Water.
There's water. What else?
NH3.
Is there any of this?
Yeah.
Yeah, it's only a
weak.
weak base, so you have a significant amount of NH3 still there
Wait, how do you
that hasn't reacted yet.
How do you?
Anything else?
Oxygen.
No, that's it.
Oh.
That's it. Just those terms are what you would
You
find
don't have enough
in this
information.
solution. Now, why do they ask major species? Are there any minor species? What would be present here but in a very tiny concentration? What?
Oxygen.
No, the water is a major species. There's a lot of water. It's more water than anything.
NH3.
No, the water is the ammonia is a major.
OH.
That's
O2.
still, all these things that are up here are major species present. You're missing
Oxygen.
something.
Oxygen.
No, there's no oxygen unless it's like dissolved in
Hydronium?
water.
Oh.
That's not part of. Yes.
That's what I said.
What?
Oh, what'd you say?
I said H3O.
Oh, I thought you said H2O. I'm sorry, Jason, I didn't hear
Oh,
you.
man.
All right, now listen. You know how water on its own breaks up into hydrogen ions and hydroxide ions?
Yeah.
On its own. Before any NH3 was added to this solution, this was going on. So there's already some hydrogen and some hydroxide present. Now we throw the ammonia in there, and this concentration goes up. What happened to the hydrogen concentration? It goes down a lot. So it already was small at the beginning, but now it's even smaller than small before. So this would be a minor species present. There's a little bit of hydrogen there. You can measure.
Yeah, so it's
No,
not.
it's not.
So
It's not a major.
So it's not H3O. It's the hydrogen ion.
It's really H3O.
Okay.
We talked about this
Oh, yeah,
already.
yeah.
Okay, so now would you go ahead and determine the OH concentration and the pH? No, yeah, go ahead. You can uncover. Go ahead. You're going to need something. Keep going.
Yeah, do we have all the info?
No.
Alright, good.
What do you want?
The like acid from the back of the table or something?
Yes.
Alright,
Yeah,
good.
yeah,
The
just
K
uncover
value?
all
The K value, because I was like, what?
We need the K
KB.
value, don't we? Can you determine how
No,
much this
you
equilibrium changes if you don't know the K value?
Yeah, I got an equation and then I was like, there is no K value to equal it to.
Yeah, you have to look it up. I had a question last hour. Somebody said, I got to one of the problems and I couldn't do it because I didn't know the Ka.
Ooh.
Yeah, you did.
Not paying attention.
Oh, dang.
Clearly
Yeah,
not.
some of them you have to look them up. It's in the back in the Ka table. Now there's also a Kb table. We need a Kb for this one, don't we? All right, I'll show you this one.
Illuminati.
Hey, you'll see later.
What?
All right, I want you to look. I'm trying to squeeze all this in on the same page. Do you find ammonia?
Yeah.
Top one. Now, before you just scan over, I want you to look down here. Look at all these chemical formulas. What do you see in common? C's, N's. Yeah, there's all these amine compounds. You know how we talked about bases? This is the Kb table. So it tells you what the base is. It tells you what the conjugate acid is. I don't think you really need that yet. Because it just adds to where So the Kb value for ammonia is 1.8 times 10 to the negative 5. Would you take a moment and try this?
Wait, I have a question.
Yeah. I think we can. If the K value is 10 to the negative 5th or smaller, then we'll use the 5%. Yeah.
Oh, I was just gonna ask. Okay, so there you get the hydronium ion because there's HA plus H2O. But here there's only H2O dissociated. So where does the H3O come from initially?
Because really the dissociation of water really is this.
Okay.
That's what dissociation of water really should be.
Okay.
We simplify by using H plus. It's just a simple way of writing it.
Okay.
In,
And then,
in reality, it's this.
but there, because there's another acid, the H2O and the H3O, like, because it go like the H is taken off, goes to the water. That's why it's H3O.
Yeah.
Okay. But here,
Well, this is different because it's a base. It's taking a hydrogen.
yeah, no. I was just talking about the top reaction because you said something on a minor species.
Yeah, so the hydronium would be a minor
Okay,
species.
because it's two. Okay, that makes sense now.
Because this is going up with the addition of this, so that has to go down.
So you have to balance it.
It's like 600 photos.
Balance.
Yeah, no. Now it is.
No, I didn't
Did you say
even
it was
get.
1 times
I
10
didn't
to the
even get to
negative
the end. I think it's like 600.
1.8 times 10 to the negative 5th. And using the 5% rule is quick and easy, right? Fast forwarding, hopefully, through your ice table. You get that? Yeah? Yeah. And Ka, no, I said Ka. It's not right, it's Kb. Kb equals 1.8 times 10 to the negative fifth equals x squared over 0.15 minus x. And we love that 5% rule because that means that minus x term we neglect.
Ooh, we got lucky. It was only 1%.
So solve for x. And what do you get for x? The value of x?
0.00164.
0.0016. I'm only using 2 sig figs. Our K's typically only have 2 sig figs. So I cut it up in 2. Can I get a witness on that though? Do we trust this guy?
I'll be a witness.
No?
Seems like it.
Just kidding. Yes, we do. 0.0016. Now, am I rushing? Did everybody have a chance to get this value? Multiply by 0.15, then take the square root.
I put in 10.
Huh?
I put in 10. I put 10 to the negative.
Oh, yeah. All right. Now, what does the x value give us? How is this relevant to what we're trying to find? The question is calculate the hydroxide concentration and the pH. What's this?
The
This
concentration.
x term is the concentration of hydroxide. So this is one of our answers right here. This is the OH concentration. Now, how do we find the pH if you know the hydroxide concentration?
Take negative log of that and subtract it from
Right.
14.
You know that when we take negative log of this, that's called the POH.
Oh.
Find it, and then just subtract it from 14. Or
11.
you could use that KW expression. Take that, divide it into 10 to the negative 14, and then take negative log of that. Either way, you're going to get the same thing.
I found my PO.
What do you get for the POH if you just take negative log of this?
Yeah, you can just use the KB, right?
9.
That's given to find the. Also, essentially, you could have found
What are you
the.
even talking about?
No, you could have just used that KB and divided by the KW.
Not the K, no.
Isn't that the relationship? KW equals.
That would be the Ka of the ammonium ion. That's not what the question's asking.
Yeah, that's correct. No.
What?
We're trying to outsmart things. Don't.
Okay.
We're trying to determine what the hydroxide concentration is.
Okay.
Solving for x. You're doing a different problem. Based on the concentration initially, the x value is the hydroxide concentration, 0.0016. What is the POH of this number?
2.79.
2.78.
8.
POH equals 2.78. All right, now if any of you out there are a little bit hung up on sig figs, like you're one of those people that always wants to have it right, I got a new sig fig rule for you. Did you wake up this morning expecting a new sig fig rule?
Yeah.
No.
Wow, we were so surprised.
Why?
Oh man.
Chemistry dreams. So good. All right. Here's a new sig fig rule for you. We know addition, subtraction. We know multiplication, division. But what about when you take the log of a number? When you take the log of a number, however many sig figs were in that number, in this case there were 2, that's how many sig figs should be on the right side of the decimal after you take the log. Here's why. Because this 2 is an exact number. Remember, a log is 10 to what power equals that number? We know with certainty it's 2 point something, but these numbers after the decimal are what's measured. So again, and you know what? You just use 3 sig figs every time for every answer you get if you're not a sig fig person. But if you are, and you want to have it right, however many sig figs your number has, that's how many should be past the decimal into your pH, or POH.
Are we doing the lab this week?
Thanks for asking that.
You should have been.
Now, that's the POH. The question is, what's the pH? So don't forget you have one more step. You've got to subtract from 14. Yeah? So pH equals 14 minus this number, which is 11.22.
That mental math.
That's right, isn't it?
Wait, I have a question.
Anybody have any question about that? Adi?
No, I did it this way. Like, I took the negative log of the OH concentration. But if you have the KW of water and the KB of that, can't you find, like, the KA?
That would give you the Ka of ammonia, but that doesn't do us any good in this problem.
Okay. Oh, okay.
We have about 20 minutes left. Would you care to grab a whiteboard and a partner?
Try a couple of these.